Imagine you are building the world's most advanced factory. You find the best robotic arms in Germany, the most efficient conveyor belts in Japan, and the smartest AI controllers in Silicon Valley. You buy them all, bring them to your site, and suddenly realize none of the plugs match. The German robots need a specific voltage, the Japanese belts use a different metric system for their bolts, and the AI controller speaks a language the others don't understand. This is exactly what happens when a company decides to go multi-cloud without a networking strategy. They have the power of AWS, the enterprise integration of Azure, and the data analytics of Google Cloud, but they are all stranded on their own islands, unable to talk to each other. Today on Cloudcast, we are going to build the bridges, lay the undersea cables, and translate the dialects of the Big Three to demystify multi-cloud architecture.
That sounds like a logistical nightmare, Ninja. I'm glad to be here, but I have to be honest. As a junior developer, I usually just spin up a virtual machine or a container in one provider and call it a day. The idea of managing 3 different providers at once sounds like I'm asking for 3 times the headache. Why are we even doing this? Is it just for people who can't make up their minds?
It's a fair question. It's not about indecision, it's about sovereignty and specialized tools. Think of it like a professional chef. You might get your knives from Japan, your ovens from France, and your spices from India. You do it because you want the best of each world. One cloud might have the best machine learning tools, while another has a better pricing model for long-term storage, and a third might be where your legacy enterprise ops already live. But the problem, as you hinted, is that these clouds weren't built to play nice with each other. They were built to be walled gardens. They want you to stay inside their fence. My job, and the job of any cloud architect, is to knock those fences down and build a superhighway between them.
Okay, so if we are building a superhighway, we need to start with the basics. If I have a server in AWS and a database in Azure, they can't just see each other by default, right? They're on totally different networks.
Exactly. Let's start with the vocabulary, because that's the first gap. In AWS, your private sandbox is called a VPC, or Virtual Private Cloud. In Azure, they call it a VNet, or Virtual Network. In GCP, it's also called a VPC, but it behaves very differently. It's like the difference between British English, American English, and Australian English. You'll understand about 80% of it, but that last 20% where a biscuit becomes a cookie or a boot becomes a trunk is where the accidents happen.
So how do we actually connect them? If I'm sitting in my AWS VPC and I want to send a packet to an Azure VNet, what is the physical path that data takes?
You have 3 main options, and they're like different modes of transportation. The first is the most common but the least reliable, the public internet. You set up a VPN, or virtual private network, between the clouds. This is like driving a car on a public highway. It's cheap, it's easy to set up, but you're at the mercy of traffic. If everyone is watching Netflix at the same time, your database synchronization might crawl to a halt. You're also encrypted, which is good, but the latency is unpredictable.
That sounds risky for a production app. What's the upgrade?
The upgrade is a private connection. In AWS, this is called Direct Connect. In Azure, it's ExpressRoute. In GCP, it's Cloud Interconnect. Think of this as building your own private railway line between the clouds. You're not on the public highway anymore. But here's the trick. AWS and Azure don't have a secret tunnel connecting their data centers directly. To make this work, you usually need a neutral third party, like a co-location provider. Companies like Equinix or Megaport act as the grand central station. You run a line from AWS to the station and a line from Azure to the station, and you patch them together in the middle.
So it's literally a physical cable in a room somewhere?
At its core, yes. Someone is plugging a fiber optic cable into a switch that connects your AWS environment to your Azure environment. This gives you massive bandwidth and incredibly low latency. It's the gold standard, but it's expensive.
Let's talk about the Babel problem you mentioned. Even if the cable is there, don't the networks still speak different languages? I've heard IP addresses are a huge pain in multi-cloud.
You hit the nail on the head. This is where most junior architects lose their hair. It's the problem of overlapping CIDR blocks. Imagine you're the postmaster. You have a house at 100 Main Street in the AWS neighborhood, but there's also a house at 100 Main Street in the Azure neighborhood. If a letter comes in addressed to 100 Main Street, where do you send it?
The system wouldn't know. It would probably just fail or send it to the local one.
Precisely. In a single cloud, you can manage your IP addresses easily, but in multi-cloud, you have to be a master of the map. You have to ensure that every subnet in every cloud has a unique range of IP addresses. If AWS is using the 10.0.0.0/16 range, Azure better be using 10.1.0.0/16. If they overlap, the routers get confused, the packets get dropped, and your application dies. This requires a master spreadsheet or an IPAM tool, IP address management, that acts as the single source of truth for the entire planet of your architecture.
That sounds like a lot of manual planning. Is there a way to automate that, or is it always going to be a game of Tetris with numbers?
It's getting better with automation, but the planning stage is still very much a human-driven process. You have to think about growth. If you use up all your numbers today, what happens when you launch a new microservice next year? You're stuck. But the real aha moment for many comes when they realize they don't have to connect every single thing to every other thing. We use something called a hub and spoke model.
Like a bicycle wheel.
Exactly. You pick a hub, which might be a central VPC or a specialized network appliance. All your other clouds, the spokes, connect only to that hub. The hub acts as the traffic cop. It handles the security, the firewalling, and the routing. This way, instead of a messy web of connections where everything is talking to everything, you have a structured system. If you want to add a fourth cloud tomorrow, you just plug one more spoke into the hub.
Okay, so we have the physical connection, we've sorted out the IP addresses so nobody is confused about where they live. Now I'm worried about the cost. I've heard people say that moving data out of a cloud is like trying to leave a casino. They make it very easy to come in, but they charge you for every step you take toward the exit.
You're talking about egress fees, the silent killer of cloud budgets. Cloud providers are like the ultimate Hotel California. You can check out anytime you like, but your data can never leave unless you pay the ransom. Usually, it's free to move data into a cloud, but they charge you by the gigabyte to send it out over the internet, or even over those private connections we talked about.
So if I have my front end in GCP and my database in AWS, every time a user loads a page, I'm paying AWS to send that data to GCP?
Every single time. If your app is chatty, meaning it makes a lot of small requests back and forth, those pennies add up to thousands of dollars very quickly. This is why data gravity is a core concept in multi-cloud networking. You want to keep the data and the things that use the data as close together as possible. If you're doing heavy data processing in GCP, move the data there once, process it, and only send the results back. Don't try to stream raw database rows across a multi-cloud link unless you have a very large checkbook.
That makes sense. Keep the heavy stuff local. But what about security? If I'm opening up these bridges between clouds, aren't I just creating more ways for a hacker to move from one to the other? If someone breaches my web server in Azure, can they just walk across the bridge into my crown jewels in AWS?
Only if you build a bridge without a toll booth. In networking, those toll booths are firewalls and security groups. The challenge is that an AWS security group doesn't know what an Azure network security group is. They don't share policies. This is the identity gap. To solve this, you need a unified security layer. Many architects use a zero-trust approach. You don't trust a packet just because it came across the private bridge from Azure. You treat it as if it came from the public internet. You inspect it, you verify the identity of the service sending it, and you only let it through if it has the right credentials.
So instead of trusting the network path, you trust the individual application or user.
Bingo. We call it decoupling security from topology. It doesn't matter if the packet came from the cubicle next to you or a data center in Dublin. It has to prove its identity at every gate. This is often done using a service mesh like Istio or Linkerd. It creates a sort of encrypted sidecar for every one of your services, and these sidecars talk to each other across clouds using their own encrypted language, regardless of what the underlying network looks like.
I think I'm starting to see the big picture. Multi-cloud networking isn't just about the wires. It's about creating a translation layer so that 3 different ecosystems can function as one. It's like we're building a United Nations for data.
That is a perfect analogy. And just like the UN, it requires a lot of diplomacy, a common set of rules, and a lot of translators. To recap, you need a physical path, whether it's a VPN or a private line like Direct Connect. You need a logical map, meaning unique IP addresses for everyone. You need a traffic cop, a hub and spoke model to manage the flow. And you need a universal security protocol like Zero Trust or a service mesh to make sure everyone is who they say they are.
It's a lot to take in, but it's not as mystical as I thought. It's really just traditional networking principles applied to a much larger, more expensive scale.
Exactly. At the end of the day, a packet is just a packet. It wants to get from point A to point B. The fact that point A is owned by Jeff Bezos and point B is owned by Satya Nadella shouldn't matter to the packet. Our job is just to make sure the roads are paved and the signs are clear.
I think the aha moment for me was the hub and spoke thing. I always pictured multi-cloud as this tangled mess of every server talking to every other server. But if I just think of it as everything connecting to a central switchboard, it feels much more manageable. It's like having a home base.
That's the sign of a true architect in the making. Simplification is the ultimate sophistication in the cloud. If you can take the chaos of 3 global providers and boil it down to a single hub, you've won half the battle.
So if I'm a dev and I'm told tomorrow that we're moving our analytics to GCP but keeping our app in AWS, I shouldn't panic?
Don't panic. Just ask 3 questions. How are we connecting the pipes? Do the IP addresses overlap? And who is paying for the egress? If you have the answers to those 3, you're already ahead of 90% of the people out there.
This has been eye-opening, Ninja. I feel like I can actually look at a multi-cloud diagram now without my brain short-circuiting.
That's what I love to hear. Networking is the foundation. You can have the fanciest apps in the world, but if the plumbing is clogged, nothing works. We've laid the groundwork today. Next time, maybe we'll talk about how to manage the identity of the users walking through these pipes. But for now, just remember, keep your IPs unique and your egress low.
Words to live by. Thanks for breaking it down for me.
Anytime. And to everyone listening out there, thanks for tuning in to Cloudcast. We've bridged the gap between the big 3 today, but the cloud is always expanding. Stay curious, keep building, and don't let the egress fees get you down. I'm the Network Ninja, and we'll catch you in the next layer.
See you in the cloud.